Well, welcome back to another lesson in our Common Core Algebra 2 session. Tonight's focus is on the word discriminant. Before we dive in, let's review the quadratic formula. So go ahead and label that in your notes, and let's nicely write that out. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, and I just want to remind ourselves, when do we use the quadratic formula? Well, that's when we're in the form y equals ax squared plus bx plus c. We're trying to solve. Now, the word discriminant is probably new to you. However, the formula for it isn't. The discriminant formula is b squared minus 4ac. Does that piece look familiar at all to you? B squared minus 4ac? Well, I hope so, because it's actually part of the quadratic formula. Take a look back up here at your quadratic formula. B squared minus 4ac is just the part that's sitting underneath the radical. So let's go ahead and write that in our notebook. The discriminant is the part of the quadratic formula sitting under the radical. Okay, so we've got another formula to put in our memory book there. B squared minus 4ac, known as the discriminant. Okay, for these three problems, we're going to use the quadratic formula to solve, then calculate the discriminant. So let's start on part A. Now remember, the quadratic equation is ax squared plus bx plus c. So let's just quickly identify a, b, and c. The a is the number in front of x squared, which there's always a 1 if you don't see one, because there's 1x squared. The b is with the x. Now, do you see a b in this case? I would say no. So the number that represents nothing, of course, is 0. And my c is the constant, so I'm going to say negative 9. Now we just throw it all together. X equals negative b, so negative 0 plus or minus the square root. Use parentheses 0 squared minus 4 times 1 times negative 9 all over 2a, 2 times 1. So let's see, we get x equals 0 plus or minus, let's see, that's going to get me the square root of 36 all over 2. Square root of 36 is going to be, now notice I'm not going to lose that plus or minus. I'm going to say plus or minus 6 over 2, which turns out to be plus or minus 3. So I would say we have two solutions, negative 3 and positive 3. All right, let's go get this. Oops, I didn't finish. Now it says calculate the discriminant. So I can write it all out. B squared minus 4ac is that discriminant formula. And again, I'm just using my a, b, and c here. My b squared is 0 squared minus 4 times 1 times negative 9. And my discriminant is 36. All right, let's try the second one. I need to identify my a, my b, and my c. So a equals 1, b equals negative 6, and c equals 9. So again, let's throw it all together. X equals negative b, so positive 6, plus or minus negative 6 squared, notice the parentheses, minus 4 times 1 times 9, divided by 2a, divided by 2. So I get x equals 6 plus or minus, it's going to be 36 minus 36, which of course is just 0, divided by 2. So I get x equals 6 plus or minus 0 is nothing, divided by 2, x equals 3. So you notice this time I only got one solution. On the previous question I had 2, negative and positive 3, but in this case I only got one solution. Let's go ahead and calculate that discriminant. Remember, that's just the part under the radical, b squared minus 4ac. We'll just verify we get the same thing. So negative 6 squared, again notice those parentheses, minus 4 times 1 times 9, and yes indeedy, we get 0. Alright, one last one to go. So let's identify again, a equals 1. Notice there is no b term, b equals 0, and c equals a positive 9 this time. So x equals, do you notice I'm starting with quadratic with x equals every time? Guess what, guys? That's a big deal. We're solving for x. Make sure that's there. Okay, so negative b. So 0 plus or minus the square root of b squared, 0 squared, minus 4 times 1 times 9, all over 2. I get 0 plus or minus the square root of negative 9, all over, I'm sorry, negative 36, all over 2. So that gets me x equals 0 plus or minus, what happens when you take the square root of a negative? Don't forget you actually get that imaginary number I. So this time I'm not getting 6, I'm getting 6i all over 2. So I'm going to get x equals plus or minus 3i. So just to remind you, that's a positive 3i and a negative 3i. And again, I'm just going to use the discriminant formula just to verify to you that it is the number under the radical, b squared minus 4ac. So again, that was 0 squared minus 4 times 1 times 9, which is a negative 36. All right, now why the heck did we do all this? Well, let's go ahead and pose that question in your notebook. How does the value of the discriminant for each relate the number of solutions you found? Okay, how does the value for the discriminant, of the discriminant relate to the number of solutions you found? So you notice I rewrote mine out here. You can probably just look at your notes and compare with me. So for the x squared minus 9, I got 2 solutions, and my discriminant was 36. I want you to take all this in. For this equation, I got 1 solution, and the discriminant was 0. For this solution, I got imaginary solutions, and my discriminant was negative. Does any of this make sense to you? Well, I think the one that should make the most sense would be option 3 here. Notice we had a negative number, and the discriminant's the part under the radical. When you get a negative number under the radical, you better be getting solutions with I in them. Okay, so I think that one makes a lot of sense. Here, I got a positive number, and I got 2 solutions. And here, I just got 0, and I got 1 solution. So we're going to tie this all together in just a moment, but those are what you kind of want to be looking for. So go ahead and title this the discriminant summary, and we're going to list each of these out. So these are the 3 options you need to understand. If the discriminant is positive, there are 2 real solutions to ax squared plus bx plus c equals 0. Number 2, let's make sure we're underlining the key words here. If the discriminant is negative, there are 2 complex solutions to ax squared plus bx plus c equals 0. And lastly, if the discriminant actually equals 0, there is only 1 real solution to ax squared plus bx plus c equals 0. Okay, so those are the 3 we have to keep straight. And like I said, I think this one's probably the easiest. If your discriminant's negative, you should understand they're imaginary. If it's positive, then they're real. And you just got to remember, if you actually get 0, there is only 1 solution. Okay, compute the discriminant of the quadratic equation. Use the value of the discriminant to predict the number and types of solutions. Then find all real and complex solutions and make a sketch. Alright, so the first part said, we'll just kind of slow down here, compute the discriminant. So remember, that's just the part under the radical, b squared minus 4ac. Alright, so let's see, my b is 2, so 2 squared minus 4 times 1 times 1. I get 4 minus 4 equals 0. So what is that you should know by now? So go back and look at your cheat sheet on that discriminant summary. If the discriminant equals 0, how many solutions do you get? So let's make a note, we get 1 real solution. Okay, so now the directions say, now go find that solution, and watch how easy this is. I already did half the work. All I need is my negative b plus or minus the square root. You just did all this because the discriminant you just found out was 0. All over 2 times a is 2. So I get negative 2 plus or minus 0 is gone, divided by 2. X equals negative 1. The last part now says make a sketch. Okay, so we're going to do this without a calculator. Think about what you just said you found. The solution, where the graph crosses the x-axis, is at -1, and it only hits once. There is only one real solution. We know it's a parabola. We know the parabola opens upward because that's a positive x squared, and we know it's only hitting this point once. So our graph should look like this. Okay, I can only cross the x-axis once, and that's at -1. We refer to this graph when it sits on the x-axis. Let's make a note. This is called tangent to the x-axis. Do you remember talking about the word tangent line and secant line back in geometry? A tangent is a point that only touches once here. So this is tangent to the x-axis. It only hits that x-axis once. So let's go ahead and label that word in our notebook. I'm sure you'll see it on a quiz. All right, same rules. X squared plus 4 equals 0. So let's go get our discriminant. So A equals 1, B is not there, B equals 0, and C equals 4. So remember, it's just the part under the radical, b squared minus 4ac. So I'm going to say that 0 squared minus 4 times 1 times 4. Notice I'm going to get a -16. So what does that tell you about the graph, about the solutions? The second I know I'm getting a negative under the radical is I'm going to say that my solutions are going to be complex, and I'm getting 2 of them. So 2 complex solutions. All right, so now let's go ahead and find those exact solutions. So x equals -b plus or minus the square root. Now remember, we already did the math there. -16 divided by 2a. So I get x equals 0 plus or minus. Remember that negative under there is telling me I'm going to get a 4i all over 2. So I get, if I divide that, that's 0 divided by 2 plus or minus 4i divided by 2. Obviously that's 0, that means nothing. I get plus and minus 2i. So just like we predicted, we should be getting imaginary complex solutions, and 2 of them. Now the big question, what does that tell you about the graph? Let's think about that. The solutions are where your graph crosses the x-axis. This is a big one. If my solutions are where my graph crosses the x-axis and they're imaginary, guess what? You can't see them. They should never touch this x-axis because they don't exist. They're imaginary. Well, let's try this. Let's go with that equation was x squared plus 4. Let's just plug in some values and see what happens. When x is 0, 0 squared plus 4 is 4. When x is 1, 1 squared plus 4 is 5. When x is 2, 2 squared plus 4 is 8. And I'm just going to pick some negative numbers to plug in as well. When x is -1, -1 squared is 1 plus 4 is 5. When x is -2, I get 8. So let's plot that. At 0, I get 4. At 1 and -1, I get 5. At 2 and -2, I get 8. Let's go ahead and connect that parabola. Can you see what it's doing? This parabola is either going to sit completely above or completely below the x-axis, depending if it's a positive x squared or a negative x squared. Okay, so like I said, this is a big one. When you have complex solutions, let's go ahead and make a note. The function sits above or below the x-axis. It never touches it. Okay, because again, they're complex and they should not be any solutions. It should not be touching that x-axis. All right, 9x squared minus 4x minus 14. So let's go get our, just our discriminant. B squared minus 4ac. So notice parentheses -4 squared minus 4 times 9 times -14. Oh baby, I get, what is that, 520? All right, so that'll help me with my solutions. Because I'm going to say it's x equals -b plus or minus the square root of 520 divided by 18. Okay, now this one's a little uglier because I got to break that radical down. Oh boy, let's say, I think it's 4 times 130. Radical 4 times radical 130 gives me a 520. So I'm going to call that 2 radical 130 divided by 18. And we'll work on cleaning it up. Remember, your goal is a GCF next. So I'm going to pull out a 2, and I'm going to get 2 plus or minus radical 130. Notice, I am not touching the denominator. I just pulled out the GCF of 2, and that's where a lot of us are still making mistakes. Now I can say, okay, 2 and 18 divide, and I get x equals 2 plus or minus radical 130 over 9. Okay, so what does that tell me about my solutions? Well, notice, my discriminant was positive. Okay, so I know they're not complex. It wasn't 0, so I don't have to worry about one solution. This tells me I get 2 real solutions. Now, they just don't happen to be nice, that's all. I'm getting 2 real solutions, they're just not the prettiest in the world. So what is that going to tell me about my graph? That means I'm going to touch the x-axis twice. And I know I'm opening upward because that was a positive x squared. And it would be 2 plus radical 130 over 9 and 2 minus radical 130 over 9. So let's kind of put it all together. The discriminant is extremely useful. First of all, it's b squared minus 4ac. It's the part that sits under the radical of the quadratic formula. It describes, okay, I like the D word, the discriminant describes the solutions. So let's just review what we could have. If the discriminant is negative, we know there are 2 complex solutions, and the graph is either going to sit completely above or completely below the x-axis. It should never touch. So the summary should be in your notebook. If the discriminant is positive, there are 2, this time instead of being complex, they are real solutions. So we should touch the graph twice. I'm sorry, we should touch the x-axis twice. If the discriminant is actually 0, that means there is 1 real solution. And it should only touch the x-axis once, and we call that tangent to the x-axis. Alright, well that does it for discriminant, and we look forward to a lot of great practice tomorrow. Have a great night.